One wall obviously surrounds the circle, and the other one, the other inscribed polygon, gets closer and closer, so you just sort of expand the polygon all the way by putting more edges into that and getting closer to the circle essentially. So in other words, what I'm trying to say is, like, if you really want to get to the area or circumference of a circle, you still need to use polygons to work with. But this is a pretty nice estimation, to be honest with you, because I have a decimal somewhere. Let me just find it out. You put only one, let's say, triangle inside, one triangle outside. Well, you know that, let's say, the circumference of the circle should be less than the circumference of the outer polygon, outer triangle in this case, right? And obviously greater than the inner circumference of the inner triangle, right? Keep doing that. You see that? You get extremely close to the circle. But this is technically how people got to the number pi. That was the reason I wore this t-shirt. How do you estimate that pi guy, right? How did people come up with this? By using this idea here. Because they discovered that circumference or the area is proportional to that number pi. Even if you change r and look at a or circumference, there's always a constant popping. And then in the past they said, oh, this should be like 3.1. And then by putting more polygons into the game, 3.14. So we can just check, in fact, other digits here. 159. Every time you increase the number of edges in there, you get closer and closer. And that's how you construct the pi, number pi.